Hello students, welcome to NCERT Class 6 Science, Chapter 7, Motions and Measurement of Distances. So in this session, we are going to discuss about the questions and the answers. Question number 1. Give two examples of each modes of transport used in land, water and air. Here are two examples of each modes of transport used on land, water and air. In land, cars. Cars are a common mode of transport on land, offering individual or group transportation for both short and long distances. The second one is bicycle. Bicycles provide a human-powered mode of transportation on land suitable for personal travel and short commutes. Water. Ships are large vessels used for transporting goods and passengers across oceans and water bodies. Then canoe. Canoes are small, narrow boats typically propelled by paddles, often used for recreational purposes or in rivers and lakes. The third one is air. Airplane. Airplanes are powered aircraft designed for long distance travel through Earth's atmosphere, capable of carrying both passengers and cargo. Helicopter. Helicopters are rotorcraft that can hover, take off, and land vertically, providing vertical transportation and aerial maneuvers in various applications. These examples represent some of the commonly used mode of transport in each respective domain. Question number 2. Fill in the blanks. 1 meter is 100 centimeter. 5 kilometer is 5000 meters. Motion of a child on a swing is periodic. Motion of the needle of a sewing machine is periodic. Motion of wheel of a bicycle is circular. Question number 3. Why can a pace or a footstep not be used as a standard unit of length? A pace or a footstep cannot be used as a standard unit of length because they are subjective and vary from person to person. The length of a pace or footstep is dependent on an individual's stride length, which can differ based on factors such as height, walking speed, and personal gait. Arrange the following lengths in their increasing magnitude: 1 meter, centimeter, kilometer, and millimeter. So, 1 millimeter is lesser than 1 centimeter, which is lesser than 1 meter, which is lesser than 1 kilometer. So, this is the sequence. The height of a person is 1.65 meter. Express it in centimeter and millimeter. So 1.65 meter is equal to 1.65 into 100, which is 165 centimeter. Then 165 into 1000 mm, which is 1650 mm. Question number 6. The distance between Radha's home and her school is 3250 meter. Express this distance in kilometer. So we know 1000 meter is 1 kilometer. So 3250 meters is equal to 3250 by 1000, which is 3.25 kilometers. Question number 7. While measuring the length of a knitting needle, the reading of the scale at one end is 3 cm and at the other end is 33.1 cm. What is the length of the needle? So the length of the needle is 33.1 cm minus 3 cm, which is 30.1 cm. Question number 8. Write the similarities and differences between the motion of a bicycle and a ceiling fan that has been switched on. So first, similarity. Both the wheel of a bicycle and ceiling fan exhibit rotational motion around a fixed axis. Now the dissimilarity. The bicycle moves in a forward direction executing rectilinear motion, while the ceiling fan doesn't exhibit such linear motion. Instead, it remains stationary in terms of displacement and only rotates on its fixed axis. Question number 9. Why could you not use an elastic measuring tape to measure distance? What would be some of the problems you would meet in telling someone about a distance you measured in an elastic tape? An elastic measuring tape provides inaccurate measurements of the distance between 2 points due to the following reasons. The length of the elastic tape can vary based on applied force or stretching, resulting in inconsistent measurements. Even when measured by the same person and using the same elastic tape, the measurements can differ between multiple readings, introducing inconsistency. Measurements can also vary when different individuals measure the same distance using the elastic tape, further adding to the lack of reliability and accuracy. Question number 10. Give two examples of periodic motion. Two examples of periodic motion are: first one is pendulum. The back and forth swinging motion of a pendulum is a classic example of periodic motion. As it swings, it oscillates between two extreme points, repeating its motion in a regular and predictable manner. Vibration of guitar string. When a guitar string is plucked or strummed, it vibrates back and forth, creating a periodic motion. The string oscillates between the maximum displacement points, producing sound waves with a specific frequency and repeating pattern.